Exercise 25 and exercise 26 are not actually part of the chapter 4 material. They are an introduction into the chapter 5 material that we're going to be going over now that you're towards the end of the 4.4. So just as a mini lesson, and just a very quick lesson, is that a ratio, because it wants you to find the missing values in the ratio table. So we need to understand what is a ratio, and we also need to write their equivalent ratios. So a ratio is defined as a comparison of two quantities using division. So in this case, the ratio, the two quantities that we're comparing are the number of flutes to the number of clarinets in a band. And so what this ratio is telling me, the 7-4, is that for every 7 flutes, every 7 people that play flutes, there are 4 people who play the clarinet. So you can imagine a band, and F is going to represent flute, and for every 7 Fs that we have, every 7 flutes that we have, there are 4 clarinets. They don't necessarily have to be in a particular order for the scenario, but it's just important to know that for every 7 flutes, how many clarinet players are there? There's 4. So what if there was twice the amount of flutes? What if there was 14 flutes? Then in order for the ratio to remain the same, then that means that we also have to have twice the number of clarinet players. We need to have now 8 clarinet players. So we went from being 7-4 to 14. That's twice of 7. And if we have 14 flute players, then we need to have 8 clarinet players. Now the thing about ratios is that they have to be equal. So if 7 divided by 4, if I were to divide that out, I would get 1 and 75/100ths. And 14 divided by 8, if I were to divide that out, I would get 1. And then 6/8 simplifies to 3/4, which is still 1 and 75/100ths. So my ratios also have to be equal to one another. Now, the way that we can determine what the number in a ratio has to be if it's missing is through cross products. So what that means is I can write this ratio, the 7 flute players to 4 clarinet players, I can write that like this. This is comparing two quantities using division. A fraction is a division problem. And I can set that equal to this mysterious number here. I'm going to label that as X. X flute players over 12 clarinet players. So you might be able to just see in your head that what happened here was that we tripled the amount of clarinet players. And if we triple the amount of clarinet players, then we need to triple the amount of flute players. And that will give me 21 flute players for the 12 clarinet players that they are. Now let me show you how systematically, if you don't recognize that right away, maybe with decimals and fractions it might be a little bit more difficult to recognize. What you can do is you can take the cross product, that's where you multiply across. You can take the cross products, 4 times x is 4x, and set them equal to one another is equal to 7 times 12, which is 84. And then you can solve for x, that missing variable that you have. If I divide both sides by 4, 84 divided by 4, that's going to be 21. And so you see that we get the same number as that we did when we saw that they were both being multiplied by 3. X is equal to 21. And so if I'm going to have 12 clarinet players, then I need to have 21 flute players. And then now the interesting thing too is that we need to know is that all of these proportions are going to be the same. All of these ratios are going to be the same. So for this third one here, where we know the number of flute players, 28, but we don't know the number of clarinet players, I'll label that as C. We can either set that equal to 21 over 12, or we could set it equal to 7 over 4. It's going to be the same thing because all of these ratios have to be equal to one another. That's why I'm putting equal signs in between them. Now, personally, I would choose the 7 over 4 because that's going to give me smaller numbers, 7 over 4. And then here you might recognize that what we did was we multiplied the number of flute players by 4. And so we would just multiply the number of clarinet players by 4 as well to keep the ratios equal, because technically it's kind of like keeping the fractions equal as well. And so you could see right away that it's going to be 16. But we could also do the cross products. 7 times C is 7C. 4 times 28 gives me 112. And then both sides divided by 7 is going to be 16. So hopefully you see that, hopefully, and this is just a little introduction into what you're doing, but hopefully you're seeing like what a ratio is. We say, for every 7 flute players, we have 4 clarinet players. And that means that in order to keep those ratios, if we increase the clarinet players, we have to increase the flute players proportionally. We need to increase it by the same amount or the same magnitude in order to keep the proportions equal. And so our band doesn't sound horrible. For exercise 26, we got same thing. We've got a ratio, boys to girls. What's going on in this part, though, this ratio table, is that we're actually going down in number on this one. We're going from 6 to 3 instead of going up like we did in the last table, but still the same thing. If we have 6 boys for every 10 girls, and I know that in my second scenario I have 3 boys, then how many girls do I need to have in order for this to remain equal? Well, 6 to 3 is like you can divide 6 by 2 to get to 3, and so we would divide 10 by 2, and we would get that 6/10 has a ratio, an equal ratio of 3/5. And then we can also set that equal to the other ratio, which is going to be an X, unknown number of boys, and set that over the 50 girls. And then we need to solve for X in this case as well. Well, we have the 3/5 there. We can find the cross product. 5 times X is equal to 5X, and then 3 times 50 is equal to 150. And then divide both sides by 5 leaves you that X is equal to 30 girls. And then you're going to take those same values that you plugged in here. Those are the same values that are going to